Hi everyone, today our topic is about generic subroutines and modules. What is generic subroutines? Structured programming is a way to split your code in blocks. Subroutines is a sequence of program instruction that performed a specific task packaged as a unit. And the modules help the programmer to split their codes into small modules. It is used to group the routines and data structures. The large programs containing many methods, subroutines will be needed to perform similar operations on many different types. So we can see a subroutine add example. How to implement add in subroutine. The following code is used: string add, string A, string B, then return A plus B. Another method is it is an integer, we will add like this: int add, int A, int B, return A plus B. This double, we will again put double add, double A, double B, return A plus B. So subroutine should be written once and be capable of accepting any arguments. This idea is known as generic programming. A generic or polyformic subroutine is one that takes parameters of different types on different activations. We take parameters of different types in generics. Okay. In Java version 5, generic programming has been added. In C++, generics are known as templates. Other languages that feature generics are Ada, Clue, Eiffel, Modular, and C#. Generic modules classes useful for creating containers. Examples of containers include stack, queue, heap, set, dictionary, list, arrays, trees, or hash tables. So a generic or polymorphic subroutine is one that takes parameters of different types on different activations. Generic subroutines are needed in generic classes. They allow a method to be parameterized by a single type. Hence, our earlier example becomes vastly simplified. This public T add TA TB return A plus B. We now have a generic type T that is passed as a parameter to the add method. Hence, we can now call the code int C is equal to add 57, double D is equal to add 4569, string concat is equal to add gen erase. So how to implement generics? In C++, there is static mechanism. All of the work required to use multiple instances of generic code is handled by the compiler. The compiler creates a separate copy of the code for every instance. In Java, all instances of the generic code will share the same code at runtime. If we call some generic parameter t in Java, this behaves identically to java.lang.object except that we do not have to use cast. This is generics in C++. A generic add method in C++ is template type name t add ta tb return a plus b. To call the method add 5.67.8. So we have to write template like this: template type name t add ta tb return a plus b. To call the method, you just call add. If you want to add 56, you put add 56. If it is a float 5.67.8, you just add 5.67.8. And how generics is used in Java. You can see in C++ template type name t add ta tb return a plus b. This allows any number, integer, float, short, double to be added together. Then how can we achieve this is in Java? Public t add ta tb return a plus b. Let us perform the type eraser. The public object add is equal to object A, object B, then return A plus B. Does this compile? No, because the plus operator is not applicable to object. So we have to modify the code to make it type safe so it can compile. Public T extends T add TA TB return A plus B. We have to impose a higher bound on the type passed to the generic method. In this case, we are saying that type passed in will be a subclass of java.lang.number. Will the code compile now? So Java generics is public st extends number t add ta tb. If t instance of integer, return a dot int value plus b dot int value. If t instance of double, return a dot double value plus b dot double value, return null. Then public static void main string args int a is equal to add 56, double b is equal to add 7.9 11.3. Generic subroutines and modules in ADA. The declaration of generic sorting routine in ADA might be similar. Generic type T is private, type T array is array integer, integer range of T with the function a1, a2, 2t return boolean. Then procedure sort is equal to a in out T array. Without the with clause, procedure sort would be unable to compare elements of a following because type T is private. This is the form of generic subroutine in ADA. Generic type T is private with the function xyt return boolean, function min xyt return t. And function of minimum is given by min xyt return t is bigger. If less than y, then return x, else return y, and if end minimum. The function string minimum is a new string. Function date minimum is a new min date. This is how in generic subroutine in ADA is writing. Generic subroutines and modules in Java. Public static T extends comparable void sort T if ai dot compared to a greater than equal to 0 integer my array is equal to new integer sort my array. This is an example of generic subroutine in Java. Comparable is an interface from the Java standard library that includes the method compared to. This method returns -1, 0 or 1 respectively depending on whether the current object is less than, equal to or greater than the object passed as a parameter. This is how in C# it is written like this. C# put the type parameters after the name of the subroutine and the constraints after the regular parameter list. The compiler is smart enough to recognize that int is a built-in type and generates a customized implementation of sort. Then generics is C++, Java and C#. C# templates is the most ambitious of the three. Java 5 and C# 2.0 provides generics purely for the sake of polymorphism. Java's design are heavily influenced by the desire for backward compatibility. C# designers, though building or an existing language, did not fed as constrained. They had been planning for generics from the outset and were able to engineer substantial new support into the .NET virtual machine. So I will come with exception handling next class. Till then, bye.